Hi, everyone. Let's do a more complicated evaluation, but something that we'll see in chapter 1 at the end and also in calculus. Let f of x be 3x squared minus 2x plus 5. Given this, evaluate f of x plus h. What happens if the argument is more complicated? X plus h. And the key word to remember here is the S word, substitution. Back here, when we worked out g of 1, g of pi, we substituted 1 for t. We substituted pi for t. These are substitutions. Likewise here, we're going to substitute x plus h for x. Remember, it's a substitution. It's not just ya plus h. That's a very common error. You don't just do that. That's wishful thinking. Or as the late Carrie Fisher would say, wishful drinking. When you see something like this, think substitution. You're evaluating a function. And often f of x plus h does not break up like this or this. That's often not the case. All right, think substitution. So if f of x is this, 3x squared minus 2x plus 5, how do we even express f of x plus h? Well, again, substitution. Every time you see an x, you replace it, you substitute it with the quantity x plus h in grouping symbols. Here we have an x. Here you put parentheses, x plus h. The plus 5 just carries over. All right. Substitution. Every time you see an x, you substitute it with the quantity x plus h. To square a binomial, it's not just x squared plus h squared. It's x squared plus 2xh plus h squared, and these are all multiplied by 3. Here I distributed, we get minus 2x and minus 2h, and then the plus 5. Finally, distribute the 3. So we get 3x squared plus 6xh plus 3h squared. And then minus 2x minus 2h, that all carries over, and the plus 5. So once you get to here, you're set. If you remember the 2xh term when you square the binomial. Okay, I'll put these in purple for extra stress. If you know to substitute and you remember not to miss the middle term, the 2xh, then you should be set. You may think this is a bit of a mess. Bear in mind that at the end of chapter 1, we're going to make things a lot cleaner when we talk about difference quotients and then derivatives. Okay, finally, let's talk about some applications of functions. You see them all over the place. Physics, the position or height of a coin as a function of the amount of time since the coin was dropped from the top of a building. The temperature of a room in Fahrenheit degrees as a function of the temperature in Celsius degrees. Also kind of physics. Over here, economics, the profit that a company makes as a function of the number of units produced and sold by a company. Later on, the comedian Rodney Dangerfield will describe widgets. So we see functions all over the place. Physics, economics, all over the place. F of x, P of x, G of t, and so forth. Next time, let's graph functions, section 1.2.